with the series of videos on HPC and CUDA. And today's video, that is the 10th video, is going to be on the profiling on a high performance computer HPC using a software called NVIDIA Insights. This is a profiling software which can be installed on a Windows remote client. Now, talking about profiling of GPC CUDA program on Windows, you can access the HPC. It is nothing but a Linux machine, so using a hypervisor software like PuTTY, and that will allow the terminal and provides no GUIs. But profiling the profiling is supported always in GUIs, and this can be done using NVIDIA Insights software, and which can be installed in a Windows machine. So we can use a SCP software, which is nothing but a FTP client software in Windows, actually, which can download software and transfer software between the HPC on Linux and Windows. So usually profiling, when we do on a particular program, let's say symbol_addition.cu, it will be running from the host, and there could be multiple GPUs in parallel. Now, a typical GPU, take the case of a GPU and a CPU, the program is loaded in the CPU, and whatever data are to be used as arguments to a function which is going to be executed, a global function which is going to be executed in GPU. So first the data is in the CPU memory, they are relocated in the GPU memories, and after calculation, after kernel is launched, the results are brought back to this memory. This is basically memory copying from host to device and device to host, and then see the results in the CPU. So a typical HPC machine, which looks like this, you can see that. So let's say GPU, we have A100 NVIDIA PCIe GPU, which has approximately 13,000 cores per GPU. This particular GPU has got different versions, but this number vary from GPU to GPU. And now there is a CPU, there is a memory in the CPU, and now we have the GPU with a memory and some processing cores. And processing cores are connected to, the cores are nothing but multiprocessors. They are connected to the memory. As you can see here, a host tries to launch a kernel, and the serial code is written. Kernel launched part will be run on the GPU, then serial code is written in the CPU to display it, and etc. And you can have multiple kernels launched into the GPU. So GPU will have grids, and under grids there will be blocks, under blocks there will be threads. That's how it's configured. Now let us consider the case of CPU serial code is running here, and kernel is running in the GPU, and it may come back to the CPU serial code results. So you can see there are blocks, and the threads, multiple threads are opened here, and each thread, they can communicate each other within block using the shared memory. Here also there is a shared memory, and there is a global memory and a constant memory. constant memory is for the constants which are shared by all the threads, and global memory is also shared by all the threads. That way it is intercommunication between blocks and threads are always possible. So now for example, in our case, an HPC machine GPU node has a GPU video RAM of approximately 80 GB. And also should remember that all these GPUs are coming also with not only with it also has got the tensor cores, which is more AI compatible cores actually, which are also there. Now you can see that usually this is streaming processor, that is called streaming multiprocessor, is called SM0, and every block is represented by a convention 0 1 like this. Same way the threads are also 0 1 0 1 1 1 1 0 1 1 like this you can represent. And you can think like now in this particular case, each cuda core is cuda 0, core 0 is referring to thread this, then another cuda core is referring to this thread. Like this you can think, and there is a memory for intercommunication between them. For example, an HPC machine GPU has 108 streaming multiprocessors per GPU, and number of threads are limited to 1500 threads per multiprocessors. A streaming multiprocessor, sorry, ASM. Now, when you come into the execution of a program in an HPC machine, see, it's called a symbol called hello world actually. See, there is a CUDA device synchronized to synchronize one block and one thread. When we profiled it, to profile, we said we have to run nsys profile a.out. Then it creates a file and called a report1.sys.report, which cannot be processed here. And so that's why we are taking into a Windows client, and we are trying to FTP this into a client using WinSCP software utility and trying to analyze this, which is nothing but the analysis of a.out. So this is how we transfer the file using a WinSCP software FTP from the HPC CPU to the local Windows machine. So this is how you can do this. You can simply drag it. It's a big simple utility to transfer. Then you need to install a CUDA toolkit 12.5 in Windows. Actually, like x86, 84 is the architecture. Windows and 10 we are taken exe installer. After that, so this is how you get the software into the Windows. These are the links which you can stop and watch later. Once after it reaches Windows, actually you profile it. When you profile it, you see that it is taking 48.6 microsecond to do this action. And this comes under the CUDA GPU summary, which you can see. And further, more analysis if you try to do, and you can see that it uses every node has got 2 GPUs. In this particular case, you see GPU details they are giving. Number of threads is 7. This is the GPU number. And here, this is the second one. And you can see the details of each RP GPU. Intel Xeon processor is being run as the CPU, 2.4 gigahertz, and these are the I told you A100 PCIe 80 GB is the memory. details of the GPU node. So here when we do the profiling, and we can see more in detail the kernel summary 48.6 microsecond, and then the block summary, kernel grid block summary is also visible here. One grid, one XYZ, you can see that actually one block is being used, and and this is the kernel being launched, etc. So we will go into the demonstration of this. Actually now we will get into this system. So we are trying to connect it to the remote system, the HPC system. That is the first step. So we are using the AnyDesk to connect it to the system. This is a bit slow, that is why it is taking time. So now from the PuTTY of the Windows machine, we are accessing the high performance computer which is installed within this campus. Now there is a captcha like this. After you give the captcha, it will ask for the password. After you give the password, sometimes access denies, and then you may have to do it again due to unknown reasons, network issues. This can happen. Now again we are getting into the system by logging in, and same old process of entering captcha etc. has to be given. Like this is the username, and it is asking for the password. Is not able to connect so far. We again retry. So this time it is asking for captcha. That's a good sign. So wanted to show that actually practically this kind of issues come up, and this is very common. Now this time I think we are able to log in. Yes, we are able to log in. Successful login. Soon after that, what we are going to do is we are going to show that program nano whatever program. For initially you have to connect it to the GPU. So for that you have to give this command srun -n1. That means one node we are getting allocated. At GPU also, we are allocating 2 GPUs through one node. -N1 means the node number, and this is a standard command you have to give. And now we can see sq command to view the nodes. Now it's minus user, so that means we are going to see which node is allocated to you. So now when we run this program, in order to run this you have to have the module load spec you have to do, and then you have to cut and paste this shell link into that. See this particular whatever you have to paste this shell program. So after that, actually you have to load this, like we said, actually spec load cuda version you are loaded. Now you are all set to run the program. So let's go into the program, that is LSC we do. Programs are here. Nano, we can see the file which we are trying to see, nano or vim or whatever actually. So we are right now running vector addition.cu. Now, so this is the program which we have already gone through. Now we are going to make a profile. We are going to run this, save it and come out, run this nvcc, this particular thing, and it will make a .cu file. Now is giving some warnings. So what we can do is actually we can go back and see why these warnings are coming. But let's say we can probably ignore this and see, and due to lack of time we will not go into the editing of this, but it's giving a segmentation fault due to some reason. So what I think I think for the time being we'll stop the video here. We'll see in the next video. Thank you.